There's three elements. If we look at on that side, this is another node as well. This also connects three elements, but because this is grounded, we just look at on the top because this is just urgent. So nodal analysis uses the first principle of Kirchhoff's current law by looking at current entering and leaving the node, which should be equal in value. What it means is it is looking what is entering into the node and compares what is leaving current from the node. The summation of these two should be equal or should be 0 when we add them, right? So, for example, if write the node equation for the circuit shown below. So let's write an equation for the node analysis. So for example, at node 1, so let's say at node 1, which is at V1 also, so we can write the current entering the circuit is -8, because it is entering, we can donate it. We can just do like this. It is just, let's say, we can argue for entering the circuit or the node, we can say minus and then leaving plus. So this is, for instance, -8 milliamps. But you need to remember it because it's Kirchhoff's current law, we always has to be based on current. And then on V1, to find the current, so that if we look at on this one, we can do V1 minus 0, which is 0 because this is grounded, over 5 kilo ohm, 5k. So voltage divided by resistance is of course current. And then we can, and again plus V1 minus V2 divided by 10k is equals to 0. What does this mean is, so they means it becomes like this. So if we look at on this one, so we created, this is entering the circuit, and then these two are leaving. So this current coming from that side, and then leaving the node, and then leaving the node. So that's why we just put plus plus. Leaving the node plus and entering the node minus, which means equals to 0. Okay, so we can read off the denominator on the bottom, just to simplify the equation. So we can multiply by 10. So if we multiply this by 10, of course it will be 80 minus 80, and then this one by 10 divided 5 is 2, so 2 times V1 is 2 V1, of course 2 times 0 is 0, plus, so if we divide this by 10, 10 by 10 is 1, so V1 minus V2, V1 minus V2, so the equation will be minus 18 plus 2V1 plus V1 is 3V1, and minus V2 is equals to 0. So if we rearrange this one to make V1 as a subject, so 3V1 minus V2 will be equal to 80. So we can say this is equation 1. Again, now we need to find out what about the equation at node 2 or at V2. Right? At V2 we can do, because we're looking that side, what's coming from that side, V2 minus V1 divided by 10, V2 minus V1 divided by 10, okay, plus V2 over 5, or V2 minus 0 over 5k, and then again, so V2 minus 0 over 5k, and then plus 2 milliamp. Why we say 2 milliamp is because this is leaving the direction, leaving the circuit. Yeah. So, of course, so we don't care the direction about this one, about the on the resistance or this one, because we just have to do this one v2 minus v1 over 10 or v2 over, we have to do care about the current direction basically. So, and then now we have this equation. So we have to multiply by 10 again to rid of the denominator. So we'll have v2 minus v1 plus 2, because if we put 10 here, 10 by 5 will be 2. 2 times v2 is 2v2. 4 minus 0 plus 10 times 2 is 20, which is equal to 0. So if we rearrange this one again, minus v1 plus v2 plus 2v2 is 3v2. And then if we bring this one to that side, so it will be minus 20. So we have equation 1 and then equation 2. So now we need to solve equation 1 and equation 2 using simultaneous equation. Multiply equation 1 by 1 and then equation 2 by 3. This should be 3. Because, for example, we have this one, 3v1 minus v2 equals to 80, and then we have another equation on this one, equation 2. So we just have to make it the first as a subject. So if we look at on this one, so this one needs to be multiplied by 3. So this will be minus 3v1 plus 9v2 equals to minus 60, because if we look at this one by 3, so minus 3v1 plus 9v2 equals to minus 60. So that at least we have minus 3v1 minus 3v1. So what we do is just cancel each other, and then we can add the remaining. So minus v2 plus 9v2 will be 8v2. There's only minus 1, and then 9 is, it will be minus 1 plus 9, which equals to 8. So 8 v2 equals to 80 minus 60 is 20. So v2 will be 20 divided by 8, which is 2.5 volts. And then to find the v1, we can use either equation 1 or equation 2. So we can just substitute the v2. So 3v1 minus v2 is equals to 80. That's from equation 1, for instance. So if we just 3v1 minus v2 is equals to 2.5, 80. So v1 will be 80 plus 2.5 divided by 3 to make v1 as the subject. And then v1 will be 27.5. So current, so V1, V2, 5, 5, 2, and 8 milliamps. So that was 8 milliamps. And then that direction was that side and that side, entering into that side. And then this was the direction was that side, which is 2 milliamps. 2 milliamp, and then on here V2, V1, so 10, it's 5k, right? So now what we got is 27.5 on here, and on here V2 is 2.5 volt. What we can do is we can check it if the answer satisfies the Kirchhoff's current law to make it 0. So we have from equation 1 minus 8 milliamp, which is this one, plus V1 minus 0 over 5 plus V1 minus V2 divided by 10k equals 0. So if we substitute the value of V1 and V2 on this one, so we can look at 27.5 on here, 27.5 minus 2.5 So this is 0. What EM means is also we'll have 2.8 milliamp on here. We can also calculate what is the current on here. What is the current? Because we have the formula. So, for instance, the current V1, our 5K is this one. So the current on this one is this one, which is 27.5 divided by 5K. 27. Divided by 5K. 5K is 10 to the raised 3, which is 5.5 milliamps. And then on this one, the current on this one, which is V1 minus V2 divided by 10K. So we can find the answer of this one, 27.5 minus 2.5 divided by 10K, 10 raised 3, which is 2.5 kiloamps. So, milliamps, sorry. And then this is 2.5 milliamps. So we know that this is the current going. This one is 2.5 milliamps. The current going down is 5.5 milliamps. Okay. So what we can also find the current on this one as well. V2 divided by 5K, which is V2 was 2.5. So 2.5 divided by 5K, so which is 0.5 milliamps. So on here is again 0.5 milliamps. What does this mean is minus 8 milliamps plus 5.5 milliamps plus 2.5 milliamps is equal to 0. That is using equation 1. Or we could do using equation 2 as well, but we have to consider this one as well. So as long as it's 0, the answer is correct. But the main principle is to find the voltage using nodal analysis. So we managed to find V1 and V2. Simple as that. Thank you for watching.